Yeah, hello class. I hope we are fine this hour, not so? We feel good. Mila, are you okay? Yeah. Now today we are introducing in the third topic, not so? Yeah. And the math is so interesting. And I heard one of you say it is in her blood. That when you cut her, the blood will flow out with x is equal to 3. Okay, now, the person who claimed the mass to be in her blood, please could you answer this question? Maybe others can help. Yes, the question is to just make us have a working brain properly. The question is simple. Are you ready? Okay. Now there are several books on a bookshelf. Are you capturing that? There are a number of books on a book shelf. But one book is the fourth from the left and the 6th from the right. How many books are on the shelf? In just 1 minute. There are a number of books on the bookshelf, of which one of them is the fourth from the left and the 6th from the right. How many books are those? I can see patients trying there. 10 books. The first answer is 10. 10 books. Yes, you have an alternative?
So last week, but take that one from now on.
For now, we take hers. Yes.
So for
9 books. That's perfect. That's very good. Perfect. There are 9. Okay. Now that shows that some people are very attentive. That's good. Now let us turn to this topic 3 called the graphs. Handling graphs. Yeah. Now under there we shall divide it into subtopics. Finding the scale. Finding the scale for large numbers. Then next we shall obtaining expressions from real life situations. Then drawing graphs from expressions. That's good. Drawing graphs from expressions. Then we shall also see special graphs, and particularly these are distance time graphs. Speed time graphs, speed or velocity time graphs. Then interpreting special graphs or other graphs, interpreting graphs. Then drawing distance time graphs. Speed time graphs. And hopefully that will be the end of our discussion. It will be the end of our discussion. Yeah, now we can start finding the scale for large numbers. Could you open your graph books there? Finding the scale for large numbers. I hope do you recall this material? How we handled partly this part under graph work in senior 1, under coordinates and lines. Now, our major emphasis, we are not going to go on these coordinates and lines per se, but we shall dwell more on real life graphs. That means most of our graphs will not have negative coordinates. Did you hear that? Because real life graphs do not have negative coordinates. Only in some few special cases. Yeah. Now we want to see how do you handle the scale. How do you handle the scales? How do you handle the scales? Now I will just pose a question here that will guide us through this discussion. Example, our subtopic here is finding the scale for large numbers. Then the example right away is plot the following coordinates 0, 50, 10, 100, 30, 150, then that's 40, 200. Now we discussed and in senior 1 that the graph paper has boxes drawn at bold lines at intervals of 1 centimeter. Do you recall that? That the bold lines in the graph book are drawn at intervals of 1 centimeter. Sorry. Now, this is what we are trying to say, is that the distance from one bold line, these are thick lines, to another thick line is 1 centimeter. That means 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, 5 centimeters. Now when we are trying to interpret this scale here, we speak in terms of 1 centimeter or 2 centimeters for every unit that you are putting. Now, like I hope we shall agree that mine is at 1 centimeter. Let us agree. I'm using mine at 1 centimeter. Now, your graph, within 1 centimeter to another centimeter, you have 5 small squares. That means you'll count 1, 2, 3, 4, and 5 on the borderline. And that means you need to understand this first, that the divisions, each 1 centimeter is divided into 5 small squares. Now, if you took 2 boxes, you are taking 2 centimeters. 2 centimeters. Is that very, very right? You are taking 2 centimeters. Now, most of our graphs, we encourage that you use 2 centimeters, unless in special cases where the things are not fitting very, very well. But we encourage use of 2 centimeters to avoid the congestion in the work. Do you pick that? Yeah. Now I want you to we be attentive here. We are going to count together. During your normal plotting, of course, you leave some space, like 4 boxes, 1, 2, 3, 4, to cater for writing the scale and the title. That very right? Then this way, during plotting, you either leave 1 box or you leave 2, depending on how values are fitting here. Then down also leave 1 or 2 boxes. That means you can either draw a horizontal line here or draw it here, depending on whether values are fitting or they are not fitting. Now, that means that's how we handle a graph. Leave 4 boxes up, leave 1 or 2 this way. Generally, we normally leave 2. We leave 2 down, leave 2 besides. That means we draw a vertical line here, up to here, then a horizontal line there. Clear? Now, the remaining space from the 4th box here to down, we can count. Like if I draw my line here and I'm skipping 2 centimeters, that means I'll count 1, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 2 centimeter gaps for plotting vertically. Then horizontally, 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 gaps for plotting. Okay. Now that's there. We've agreed 10 vertically, 8 horizontally, 2 centimeter gaps. Clear? Now, during plotting, we identify vertically which value is the smallest and which value is the highest vertically. And also horizontally, we check the highest and the smallest. Now look at how we get a proper scale for our plotting. The scale can be got mentally or by calculation. Clear? Horizontally, which value is the smallest horizontally? Our x value, it is 0. Our biggest value is horizontally. The smallest is 0, of course. This stands for x, not so? This is y. Then the smallest is 0. The biggest is 30, 40. That means I will plot from 0 to 40, not so? Yeah. Now, I think that's picked. Now when we are choosing the scale, you can work it out mentally if you can. Because if you are plotting from 0 to 40, how spacing will I make to reach 40 at a wide space? See? Should we, because of course we are going to use 2 boxes for every plotting to make work more presentable and quite beautiful, because math is beauty. Yes, Grace?
2 centimeters can represent 20.
Can represent 20? 2 centimeters can represent 20. Are you really sure? Grace? She's saying that we can, because that's horizontally. If this is 0, 20, 40, do you see that your graph will end here? 10. 0, 10, 20, 30, 40, at least that's quite reasonable. Whatever student said, 5, can it make it more wider? 0, 5, 10, 15, 20, 25, 30, 35, 40. Now you use the scale that makes the graph more. Yes, because we expect the student to at least have the 3/4 of the graph page being covered. 3/4, not to hand a graph here. Narrow. Now that's mentally, but by calculation, we can get the highest minus the lowest divided by the 8. Because we counted the 82 centimeter spaces horizontally. 40 minus 0 divided by 8, you get 5. Now, the answer you get must either be, who can remind us? That means when you subtract 40 minus, this is called our interval. Interval is 40 minus 0 out of 8. That gives us 5 horizontally. Okay. Now we are trying to establish the scales. Now that is the interval horizontal. You are saying interval is 40 minus 0 out of, giving us 5. But we say this digit can be 6. Sometimes after division, you can divide and the answer is 3. But you say you round off either up or down. Up, we mean if you got 6, you would take 10. That means you would be skipping 10, 10, 0, 10, like that. We can't use, we either use this or their multiples. But we don't say, we are not saying the multiple like of 2 can be 12. You don't use 12, no, use 2, 20. Multiples in tens, in multiplication by 10. That's what we mean. You understand? Yes, either 0.1, 10, 100, like that. Okay. You understand that? Okay, work out for me vertically. How shall we put? What are the values we are going to put? The smallest is 50, 200. But if it is 50, shall we begin from 50 or a bit lower than 50? Or we start at 0? It means you can also make a choice. You can make a choice on either to start from the same 50 or to start from 20 or to start from 0 or 10. Not necessarily, these graphs don't necessarily start at 0. These real life graphs, except coordinates, when we are plotting Cartesian coordinates, you must have zeros started. But here, real life graphs don't need to start at 0 since they do not have the negative axes. Okay, to save time, if we are plotting like 200, I think we start at 0. Not so? Yeah. Vertically, mentally, you can work at that before you calculate. Mentally, how shall we put every 2 centimeters? How shall we put that? If that was our 0 here and our 0. Horizontally, we've agreed we use 5, 5. Me, I'm taking mine. These are 2 centimeters, 2 boxes. There is a box in between them. It's because of my space that I'm trying to minimize. I hope you understand that these are my thick lines. Not so? 2 centimeters, 0, 5, 10, 15, 20, 25, 30, etc. You continue until you reach what? You reach 40. Okay, vertically, help me vertically.
200 minus 50.
But we are starting from 0. That will be 200. You decide where you are going to start from, not what's here, because you've changed the starting point. Therefore, vertically we had how many boxes? 2 centimeters, 10. Now put in the mind, every time you use, you'll be using 8 and 10. Of course, you'll be a standard graph paper for UNEB has like 8 and 9. Not necessarily 10 here, but our normal books are using 10. UNEB graph paper is a bit narrow, bit smaller than this. Uses 9 and 8. You try to count, of course, not so. What do you get? 20. That automatically sends us to a better place. Not so? Yeah? 80. 160. Up to now you go up to 200. Is that fine? Okay. Assuming you got 16 here, what would you plot? 20. Now let me give you a 15. Wouldn't work. It's not in tens, not so? Yeah. It must be in tens or tenths. Tenths, I mean it is a 0.2 in case you divided and you have decimal things. Clear? Okay. Now there you are. Now I think you are plotting that right away, not so? Right away, and there is some gap here. That means you must write a title for our situation that we are dealing with in the question. But as for our plotting, there is nothing there. Just call it a graph. Then you must give us a scale somewhere here in the corner among the 4 boxes we left up vertically. But I want to put this at your attention that in translations or reflections, do not use 2 centimeters. They will disturb you in finding out the coordinates. You use 1 centi. Have you captured that at your attention? Yes. Yeah. Now I want to right away take you to another area here called coming up with expressions. Coming up with expressions. Then after identifying after coming up with the expression, we draw the respective graphs. Yes, we are through, not so. Make sure that you don't cater for a negative access anywhere under this situation that we are handling, because basically we are handling real life graphs. Is that very right? That's very, very good. That's very, very good. Have you plotted? 0 against 50. Zero against 50. Zero against 50. 0, 50, I think 0 horizontally, 50 vertically, around the middle. Not so? I hope you know how to locate even that point. Not so? You just divide 50 . Okay, 0, 50, fine. Let us plot more fast. 10, 100, 10, 100 would be right here. I hope everyone has plotted 30 against 150. Yeah. You can join them since it will be giving us what's taking place there. What's taking place there. Have you labeled every axis? Call this Y, call this X, unless the question has given you something else. Put the scale there. Vertically 2 centimeters represent 20 units. That means 1 centimeter will represent 10. Okay, now let us go to obtaining expressions from real life situations. And we shall right away draw the graphs. That means we shall handle the two concurrently. Obtaining subtopic 2, obtaining expressions or equations and drawing graphs. We are combining that together. Now let's take examples here. Are you set? I read the first example for you. Are we there? A tree is 6 meters high. A tree is 6 meters high. A tree is 6 meters high. Full stop, continue. It grows at 0.5 meters each year. It grows at 0.5 meters each year. Each year. Part A, write down a formula to show the height y. Write down a formula to show the height y in meters. In meters as a function of time. In meters as a function of time. X in years. Part B, draw a graph of the formula. Draw a graph of the formula. Then part C, use the graph to find Roman 1. Use the graph to find Roman 1. Height of the tree after 5 years. Height of the tree after 5 years. Roman 2. The number of years until the tree is 10 meters. The number of years until the tree is 10 meters. Who can guide us? Now, you see, to come up with expressions, you just depend on what the question has said, and you interpret it direct. Who can guide us through that? How can we answer part A? Who I thought, and you explain to us? Mile, have you thought? So I can see somebody, a brain cracker here. What have you thought? Height is yes, height is represented by h, and for this case, the height, original height is, the height is y. Originally it is 6 meters. Then what else is the variable there? That's the growth rate. It is, growth rate is x, which is represented as 0.5 meters. After what? It grows at that rate after every year. Oh, the x is not, what is time is x, not the growth rate. Time is x, then the growth rate is what? 0. Meters per what? Per year. But these are x years, not so. How can we express y? Yes, Grace?
So I think it's y is equal to x. No, so it's x is equal to
X. The question said express what? Write down y as a function of time. But the tree is originally 6 meters, and it will add more heights after every year.
I think
Now let us ask you maybe. Let us ask you, assuming right now you are 3 meters tall, but your height, you are adding every year 0.5 meters to your height, and you take in 5 years, how high will you be? How do you handle that situation?
You add your height plus you multiply the growth rate, that's the number of years,
then you add the original. That simply will become 6 plus 0.5 times the number of years. That's good. But Grace was just laughing at us, not so. Okay, part B said what? We draw we've come up with the formula, of course. Now the next part is draw a graph. We have to create, of course, some coordinates, just a few. But remember there, our question has some equation of 10 years, 10 meters somewhere there, and it has some time there asked as 5 years. That means our graph should exceed 5, not so? Can have 0. Some values can have some intervals to cater for many, because if I used 1, 2, I will have a table of so many. I hope, do you get my logic? That means I can end on 10. You decide on some few. Even when you use 0 and 8 only, now first wait and we agree whether the values will be fitting our things, because there is a question on Roman 2 there. You check that question there. It is saying the number of years until the tree is 10 meters. That means one of our y values must be above 10, so that on the graph we shall be able to locate 10. That right? Let's see, if we use the 10 here, 0.5 times 10. This is the mental math, guys. 5. A decimal place cancels with 1 0. That's 5. 5 plus 6? 11. I think that caters for it. Yes, we can move now. When x is 0, yes, put here 0. 6. Okay. Then when you use 2, 25.
No.
Yes, but we are saying you can start from 0, you can start from anywhere. Yes, when you have 2 here, 2 times 0.5 is 1, not so, plus that 7. 4 times 0.5, 2, plus 6. 6 times 0.5. You multiply 5 times 6, you get 30. Cancel that 0 with a decimal. See that? That's what? 8 times 5 is 40. That's 4. Plus that?
10.
Then this is 11. We plot. I think this is pretty short for you, and you label y and you label x. 2 centimeters class to be more accurate and better looking. How many plotting value for x are these? 1, 2, 3, 4, 5, 6. But we divide. 10 minus 0. Divide by horizontal. How many boxes are you using? 2 centimeters. There are 8. We agreed 8. 10 divided by 8. 1.2. 1.2 is roughly 1. That means you can use 1, 1, 0, 1, 2. If it can't fit, we shall use 2 to check on your graph, does it fit? Vertically, we also start from 0, I think, because this is 11. 0, 1 up to 11, not so? Yes. Yeah, it will fit. Will it fit? Or there will be many? We start from 1. I see them being so many because up we have only 10 what? 10 vertical boxes to use. That means since I need only 6, I can even start from 2, 3, 4, 5, 6. Go on like that up to 11 and start plotting. Keep time, keep time. In fact, write that entire question in the graph book on that page where you are plotting. Now this is X was in years and the Y was in meters. Therefore you label Y in meters and you label X in years. X in years. Okay. Keep time class. I want to read for you one more here. Have you plotted? Is it a perfect straight line? Plot everything accurately, connect. Put the scale. The title is a graph of height. Graph of height against time, not so? Write that title very well. Include the scale in this corner. 2 centimeters represent what? A graph of height against time. Okay, 0, 6. I hope you've plotted that graph very, very well. And make sure you label on it y is 6 plus 0.5x. Label on that graph. Do the following. Label the axis very well. Y in meters, x in years. Then come and label the graph here. Y is equal to 6 plus 0.5x. Put also the scale and put data. Okay, my time is running badly, therefore, Grace, why are you using 1 centimeter? Keta 4 2. Princess, have you made labelings well on your graph? The scale is not there in the corner below the title. Below the title, below the title. Does it reach up to 10?
No.
Then you'd use 0, 2. Did yours reach? That means you use 0, 2. This one can't reach 0, 2, 2, 4, 6, 8. Use 2 centimeters to avoid the congestion for every. That means 0, 2, 4. Avoid 1 centimeter very much. It makes the work looks untidy. And endeavor to leave some 4 boxes up to cater for our scale. Okay, I want now to give you another question. Grace, you seem to have drawn a smart one, and we look at it. I mean, Ruth. Have you labeled well? Label it fully. Label the title. Then label on the graph itself the Okay, now let me look at Ruth's as a demonstration. Is it having full values plotted? The scale is not there, it should be here. Then the title is there. The graph, this writing must be along on it, because this one you have plotted it. Then vertically, I don't see y in meters. This one, y in meters. Then x in years. That's very, very good. Okay, and you have used arrows on the Yeah. Let me read for you. Let us answer the question. There is something that was left there. Are you on that? After 5 years, have you located that? Locate 5 and show on the graph that indeed, because my space was not ample, was not. That means that the graph you have something like that, don't you?
Yes.
Now you go at 5, when time is 5, show on the graph that you are using the graph, we want to see that. Then locate on the vertical axis here. Locate the point there. Now I want to see how we read that point. How do we read that point? Now the easiest way to read any point is to establish what one small square represents. Now look here briefly. Look here. Each 2 centimeters has how many divisions? 10, not so? Has 10. Now, what is our scale here? We've used the 1, 1. We've skipped 1. That means 10 of them divided by, how can guide us? How do we arrive at 1? 1, in between here, I have 10 small what? Squares are representing each one what? Unit. What of one small square would be what? Somebody guide us. That one will be 1 out of 10. That means 0.1 units, not so? Now, if I'm locating my plotted point, say, let me rub this, assuming this 5, this is 6, 7, and this is 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How will I be able to locate this? Knowing that each one is 0.1. Of course, there are 2 ways, not so? You can either count 7 point what? 1, 7.2, 0.3, 0.4, 0.5, 0.6. Or else, you do count how many boxes, small squares are away from 7. There are how many? There are 6 times 0. That means 7 plus how many are they multiplied by 0.1. Or else another student would say, let me count all of them from here. How many are they? Then you would simply multiply by 0.1. But this one is easy. Count mentally, 7, 7.1 like that. Or 7 plus, how many are they times 0. Okay. Okay, that's flat. Okay, trace the 10 meters and also read. I hope you are there. Trace 10, they say read the years for 10 meters. Show on the graph that you're reading. Point the arrow, read. How many years should the tree be? 10 meters. And who has located it to the pass? Yes, Grace.
Because I used 2 centimeters for the meter.
Fine, it would give the same answer. Not so? It must give the same answer. Okay, write this question. I hope you've read that. You've read 8, some have read 9, some did go virtuous. Being a straight line, I expected the answers to be the same, since errors are not in straight lines. Okay. Write this one here. The cost of a taxi, this one I'll leave you to plot it, but we are wanting to come up with the expression. The cost of a taxi for each kilometer is 2,000 shillings. Write down an expression for the cost C. Write down an expression for the cost C. In shillings, for the cost C in shillings, in terms of distance D in kilometers. Then part B, draw a graph to show the costs Then part C, use the graph to find Roman 1. Use the graph to find Roman 1. The cost of the journey, the cost of a journey of 6.5 kilometers. The cost of a journey of 6.5 kilometers. Then Roman 2, the distance traveled, the distance traveled for 5,000 shillings. For 5,000 shillings. Now let me guide you a little there. I think we need to handle this. These are big values on money, not so? Okay. Let me see somebody guide us with the expression. Then we can conclude on that discussion there of how to come up. That's what has the question given us there?
The cost of the taxi for each kilometer is 2,000 shillings.
The cost is 2,000. It's 2,000 for each kilometer, not so? That's for 1 kilometer. Okay. Then
Write down an expression for the cost C in shillings in terms of distance D in kilometers.
in terms of distance D. This is for 1 what? Then this distance is D in kilometers, not so? Now, how will the cost be expressed in terms of distance? With 2,000 catered for? Yet 2,000 is for 1 kilometer and distance is D kilometers. How would somebody be wanting to get the cost for easy distance when by multiplication? That means the cost is always the distance for 1 kilometer times the number of the cost for 1 kilometer. That's 2,000 D. Clear? Yeah. Now, Such would be big on the graph paper. Now for cases where issues are very big, we convert, we can express the cost in thousands, and we say that the cost can now be 2D, and on our graph paper, now it will now be in thousands of what? Shillings. That means I've catered for zeros. That means whenever I'm handling the cost, I'll be multiplying by what? That's puzzling somebody's brain. It's about to crash. It's not a phone to crash. Now, we have said just remove zeros and use a value. Or you can use 20 and say in 100 so that zeros are catered for. So, okay, let me show you here. Cost, then this is the distance, not so? Okay, this distance must be put there. Distance is in kilometers. Then the cost is in what? Thousands of what? Shillings. I hope you're understanding how we cater for some funny graphs. Okay, give me some D values that we can put there. Remember, there is a question having 6.5 kilometers there. Do you see that distance? That means I must go beyond that. I can use 2, 4, 6, 8, 10, not so?
Excuse me.
Yeah, excuse very much.
How do you depend on to determine whether maybe the kilometers or the thousands in shillings lie on the X or Y axis?
Okay. Now there is what we call something that depends on the other, and one is independent. Now, one that is got from the other, one that depends on the other to get him is called a dependent variable. Like you can't get cost without distance. So the cost depends on distance. Not so? To calculate the cost, you have to have, the equation shows you that this one who is calculated using the other one is on the vertical axis. You see that? The dependent variable is on the vertical, independent is on. Yes, distance does not depend on cost. Even the expression itself tells you that C is plotted in terms of, yes. In fact, an expression of a letter in terms of the other is put on the vertical axis. So, in real life graphs, you'll never have C is 2D and D is put here. This is calculated using this. That means dependent variable, independent variable. Oh, follow the equation. C is vertical, D is, so I don't know whether I've answered you mathematician. You have answered mathematician? Okay. What is the cost here? Okay, that is 4, 8, 12, 16 and 20. Now during plotting, here okay, me I can't invert my hand. Not so, I would write like this. C in what? But allow me to write like this, because inverting my hand is a real problem. But it's better to write your things along here. If it's a long statement, invert it and say C is in thousands of what? Shillings. Of shillings. Okay, plot that. Then here you put D kilometers. Okay, class, now I want to guide you here, and I let you. I hope the scale is, how can we reach the scale? This is 20, this is 4. I can shift it to 0. Everything, since these are nearer 0, if you are nearer 0, why not 0? Therefore, 20 minus 0 divided by 10. That means every 2 boxes, 2, 2. Clear?
Yes.
Okay. Okay. Horizontally, 10 minus 0 divided by 8. 1.2. Now when you get a value above, when you use 1, the values will exceed the graph paper. Whenever you use the value lower than the scale, the values are going beyond. I hope you understand that. That means you'll use 2, 2. 2, 2. Or else you'll at least move the graph. You leave now 1 centimeter this way. I don't know if you pick that. Yes. You leave 1 centimeter. Instead of using the usual 2 boxes, leave 1 box. Then it will be able to fit when you use 1, 1. 0, 1, 2, 3, 4. Patience, are you clear? Plot that very, very fast. Yes, do so, do so, do so. Okay, class, we want to save time. Therefore, have we finished that? There are many things to discuss here, and there are many that we are yet here. 3 sections. Therefore, we need to keep what? Time, not so? Now, I hope you have plotted, haven't you? Now, 2 against 4, 2 against 4. Then 4 against 8, 4 against 8. Then 6 against 12. Plot until you finish up 8 and 10. Don't forget the arrow. 8 against, no, that's what? 6 against 12. Continue plotting until and draw our straight line there. Plot all points, then you'll join by a straight line, and you'll label that graph 2D. Are you through with that? Now I want us to answer the first question. Says, me, I'm interested in Roman 2 there. I want Roman 1. Grace, you seem to have decreased in the velocity. Please label our title a graph of cost against distance. A graph of cost against distance. Now you include our scale vertically and horizontally. Vertically, what do we have? 2 centimeters represent, now there you are, represent 2,000. Do you capture that? Represent 2,000 what? Shillings. Then horizontally, 2 centimeters represent 1 kilometer. Yep. Okay, now the first question says the cost of a journey of 6.5, not so? 6.5, where is it?
Between 6 and 7.
Because here is 7, not so? Yes. Again, 6.5 is here. 0.5 is a half before you reach 7, not so? Yes. Yeah. That means trace that. And trace that on your graph. I don't know where you'll arrive. Costs, yes. Cost for 6.5 kilometers. What have you got? The money you get here, you multiply by 1,000. You have, if you have 8.2, it will be 8.2 times 1,000. Therefore, you will get 8,200 shillings. I hope people know how to locate that point on your graph. Do you now treat that decimal point? Yes? You have got? She has got 12. Okay. You're interchanging the plotting.
No. Yes, 2 centimeters.
And no, it is fine. It is fine, but but your graph is too small. But I think because now when we are marking yours fits only here. Not so? But it's correct. It's correct, but don't plot like that for us, because we shall punish, we shall say, penalize 2 marks. Now, okay, next subtopic, special graphs. Clear? I want us to turn here very fast. Plotting is done, and people know how to plot and work the scales out. Now, special graphs. And there are 2 special to us. Others are general. Others can be in terms of height, populations, depending on the question. But for us, the special ones to us today are distance time, special graphs, and we are going to look at distance time graphs, because these ones are very important, and velocity time what graphs, or we call them speed time what. Now go to distance time graphs. Distance time graphs, they represent the distance covered after some time intervals. Now I'll use an illustration to explain and how do we interpret them, because the next part is interpreting what? Graphs. That is interpreting special graph. That's subtopic what? Subtopic 4. Then subtopic 5 is interpreting them. These graphs, how do we interpret them? Yes. Interpreting special graphs, and we are going to start with how do you interpret distance time graphs. Yeah. Now we've said they represent the distance being covered after some time intervals. It might not be regular, it might be regular. Now, let me just use a real life example. If you walk from here, let's call this point A, and you are going to point B, and that point B is where you sleep in that dormitory. Not so? You need to listen. Like when this lesson ends, you are going to walk to your dormitory, not so? You will walk home, not so? Some will walk home. Now, when you walk, let's say this time is what? What is this time? Okay. Distance we are using for us in meters. We are just walking some short distance to home. This is time in hours. Now at 8 is when 8 a.m. 8 a.m. We are just at the starting point here, point A. Now we are walking to point called point B. Now after 1 hour, that will be 9 a.m. we have walked 20 meters. Not so? Now after again 1 hour, we add more 20 meters. That's how many? 40. That's now 10. a.m. Clear? Then at 10, 40 meters finds me at the shop. I take 30 minutes buying, eating breakfast at the shop. I buy a soda. Now we're giving example. Now the next subtopic is special graphs. We've seen that we have two. Other graphs are not special, as we said earlier, because they are general population graphs, cost graphs. But what is special for us is distance time and velocity or speed time graphs. Then now we are interpreting them. How do we draw a distance time graph and how do we draw a velocity time graph? Now we are giving a scenario here of one student is going home from this place, and we are looking at the journey of the student. The student leaves the school. School is A, and is going home, which is located 60 meters from school. Now, at 8 is when the student is leaving. After 1 hour, the student covers 20 meters. Then, after another 1 hour, the student has now covered 40 meters. Then, after 40 meters coverage, he finds a kiosk and he waits to drink somewhat juice with how do you call those things? Is it crisps or what? Your accompaniments, not so? Now, in waiting, when you are waiting, the distance does not change, not so? But the time is adjusted. From there, the student goes home. The home was located 60 kilometers and reaches home just after 1 hour. That means the student is reaching at 10 what? 10:30. Now if we are to illustrate this on a velocity, this is an illustration, then we shall have a typical question. Our distance is 0 to 60. That means people know how to find the scales now? Yes. We can use that. Up to 60, of course. This is an illustration, not drawn to scale. Then the starting time is 8, but your scale is using 2 centimeters for every 1 hour, not so? That means I will go to 9, then you go to 10, then you go to 11, then you go to 12. But I'm ending at 11:30, therefore I will not exceed 12, not so? Now, starting point 0, here, not so? 20 goes with 9, that's 20. Then 40 is at 10, clear? 40 is at 10. Then waits for 30 minutes, that's up to 10 what? 10:30, this is 10 here. 10:30 is in the middle. Is that right? Yes. 10:30 is a half an hour. That will be here, but the same distance. That means a level distance, a constant distance indicates that you are resting. Then that means, now finally, he arrives at 11 what? 30, and the distance due there is 60. That's how the distance time graph will look like. Is that right? If I ask you to describe it, you can describe and say from, if it's drawn, of course you won't be able to see this. You'll say the student has for 2 hours, then rests for 30 minutes, then covers the rest of the remaining distance. In how many hours are those? For the 1 hour. From here to here is 1 hour. Okay, that's how you interpret. Now, there is a case where the student now comes back to school. Let's assume after reaching home, just drops the books, throws the books, does not rest, reaches home, throws the books, makes a U-turn, and reaches to school after 1 hour. That will be reached at 11:30, did not rest. Remember, school is this way, down. That means you must, but you don't again come here. No, when you come here, you are reaching at what? See that? That means when he returns to school, you just look at time. To reach at 12:30, yeah. Okay, that's good. That's the return journey to home, to school, yeah. Okay, now look at this. Let's take two people. Let's remove this return journey. Now, the child goes home, but the parent, by the time the child goes home, we are discussing this and we have a real graph here. Clear? Yes. Now, a child, when the child starts to move at 8, at 9 the parent is leaving home to come to school to see the child because he was indisciplined. Now, let's have the parent's information also. The parent moves equal distances for everyone 1 hour. Does not, this is the distance, this is the what? Time. He moves a constant distance of 20 for every 1 hour. Started at 9 a.m., 10, 11, 12, not so. Now, has reached at what? Now, the home is here. We must draw a line for the parent starts at what? Is starting from home. Then arrives at, does not wait anywhere. That means you will arrive, you will plot, of course 0 is 20, but this will be 0 here. That means the 0 will be the 60 this way. Will just be now reducing from 60 by 20 up to reaching what? That means the 0 will be at 12. Not so? And 60 will be at 9. Then you will go at 40 with 10. Of course, if you know only 2, if the distance, if there is no waiting, just plot this and the last one and the first one and you'll end. That means they met somewhere. And the parent slapped the what? The kid. Okay, now the return interpretation is from up to, from when people are moving in opposite directions, they use this. But if two people were moving from the same point, you would handle from the same side they are going up. Okay. Now let me read for you these questions because of time. Okay. Now there is something that I did not mention here. that equal distances covered after equal time intervals, like now when we say 20 meters per hour, what would that mean? If like now this is 20 meters every 1 hour, we can now say 20 meters per hour. That is speed, not so? Yes, that is speed. Okay? Now, before I give you a number here, allow me to first put those things here. Simple formulas. Distance is equal to, you recall that triangle?
Yes. Distance is equal to speed times time.
Speed times time. Then what is time?
Time is equal to distance divided by speed.
Distance over speed.
Yes.
And so on.
Yes.
Okay. Average speed?
Equal to total distance and
Total distance?
divided by
Total time. Not so? That's right. Okay. Now, can we convert units from 1 meters to kilometers, kilometers to meters? Since we want to draw graphs, I want you to just make some review of these conversions. We recall our King Henry's daughter drank cold milk, not so? Which one is the biggest unit? Okay. Convert A. 2 meters, 200 meters to kilometers. How do we arrive at that? People think very, very fast. 0.05 kilometers to centimeters.
1,000 meters are equal to 1 kilometer.
We trace it from where? A kilometer is here and a meter is there. We put zeros, 1, 2, 3. That means 1 kilometer is 1,000 meters. So 1 meter will be 1 over.
1,000 kilometers.
Then therefore 2 meters is 200 times, getting you down to 0.2 kilometers. Clear? Then 1 kilometer is how many centimeters? Right from here counted? 10,000, 100,000 centimeters, not so? Therefore, since I want to change that part, I will not invert. 0.05 kilometers. There are some people who fail to see how some will again invert. Now, if you are fond of making mistakes of inverting and you don't know, you just fill here and say centimeter, and you fill here what? Kilometers. Then you have 1 kilometer is going with, then what of 0.05? No, this is unknown. No, this is was what? This is 1,000. 1 goes with 100,000. Then what is this? 0.05 goes with. Then you cross what? Is that very right? That means this is 0.05 equal to 0.05 times 100,000, but since there are 2 decimal places, kill 2 zeros, it will be now 5,000 centimeters. 72 I hope you know distances. Speed is measured in kilometers per hour or meters per second. To meters per second, how do we achieve that? That means to meters, that's like kilometers over 1 hour. Therefore, how do we change it up? 1,000, because 1 kilometer is 1,000 meters. So up here first use this. Then down 1 hour must go to what? Yes, that gives us 72 over 36 is 220 meters per second. That right? You'll enjoy more with the physics teacher, but for us, because we need them here. That right? Yeah. Now, let me give you question 1, and we draw it. If you are not sure of unit conversion, practice, because you will not run away. You will not run away. Instead, you will run towards. Not so? Okay. Let me read for you this at once. On a journey, Ambrose drives 50 kilometers per hour for 2 hours. Drives 50 kilometers per hour for 2 hours, comma, rests for 1 hour, and then he drives another 70 kilometers, and then he drives another 70 kilometers in 1.5 hours. In 1.5 hours. Draw a distance time graph to illustrate Ambrose's journey. Draw a distance time graph to illustrate Ambrose's journey. Ambrose's journey. Are you together? Could we first label those distances here? There is some speed there in the question, not so? We can convert it to distance, since we are interested in distance. Distance is speed times time. What is that speed in the question? $50 kilometers per hour. Times how many? What time did he take there?
2 hours.
That's how many meters? Kilometers? 100. Okay. That means I have time and distance in kilometers, time in hours. At the start, then after 2 hours, it started at what time? Is there a starting time? No starting time. It says what? On a journey, Ambrose. That means initially at the start there is no distance, not so? Yes. Then after 2 hours has traveled 100. Then what happens? What happens? That entirely means still 100. What time is that? After 1 hour, that is 3. That's all. Now, then finishes with what? That's reaching at a total distance of 170, and that is, and now, if you are at 100 plus 70, 170, not so? 4.5 hours. Okay, that means right away go to your graph and do that. This is distance. Which scale are we using? From 0 to 170? 170 divided by 170 minus 0 divided by 10. 17. Therefore we use 20. You'll say 0, 20, 40, 60, 80, 120, 180. Now this, make sure these are 2 centimeters, please, not 1. Then this is 0 to 4. That means I can use 0, 1, 2, 3, 4, and 5. Lastly, 2 centimeters also. This is the time in what? Hours. In hours. Kilometers. Then you have to put the arrows, not so? Yeah. Plot. 0 goes with 0. 2 goes with 100. That's at 100. Then at 3 is also 100. Then finishes at 170. Make sure you finished up that. That's 4.5. Not so in the middle before 5. That's around 170. Then join with the straight lines. Next question. I hope people are right there. You are there? Okay. Now let me quote this. Quote this for you. A lorry set off at 7 a.m. from station A. A lorry set off at 7 a.m. from station A to station B. From station A to station B. 365, 360, not 65, 360 kilometers away. Together. It traveled at a constant speed of 50 kilometers per hour for 2 hours. It traveled at a constant speed of 50 kilometers per hour for 2 hours. Clear? I think we are discussing that, and we go to a velocity time graph for 2 hours. The lorry then stopped for 1 hour. The lorry then stopped for 1 hour. It then proceeded at a steady speed of 4 hours. It then proceeded at a steady speed for 4 hours to station B. Steady speed for 4 hours to station B. Is that right? Now continue. A minibus left station B at 8 a.m. A minibus left station B at 8 a.m. for station A. At 8 a.m. for station A. And moved at a non-stop for 4.5 hours. And moved non-stop for 4.5 hours. Part A, using a scale of 2 centimeters to represent 40 kilometers. Using a scale of 2 centimeters to represent 40 kilometers on the vertical axis. And 2 centimeters to represent 1 hour on the horizontal axis, and 2 centimeters to represent 1 hour on the horizontal axis. Draw on the same axes. The distance time graphs for the lorry and the minibus. The distance time graphs for the lorry and the minibus. For the lorry and the minibus, part B. Use your graph to find the A. Use your graph to find the Roman 1 to find the semicolon Roman 1. Use your graph to find the Roman 1. Time when the 2 vehicles met. Time when the 2 vehicles met. Then distance from A where they met. Distance from A where they met. Then Roman 3. Average speed for the minibus. Average speed for the minibus. One student will read for us slowly as we interpret. Yes. Yes, Ruth. We start with a lorry.
Set off at 7 a.m. From station A to B.
That means that's its time, distance. It's set off at 7 a.m. from A, yes,
360 kilometers
away. That's the total distance, not so? Go ahead.
It traveled at a constant speed of 50 kilometers per hour for 2 hours.
Now the distance every 1 hour is what? If they say 50 kilometers per hour, they mean the distance being covered after every 1 hour is 50. You understand that?
Yes.
That means the first distance, this is the start, not so? Yes. After 1 hour, he has covered 50. Then after another 1 hour, still 50, that's 100. Then at that point, after 2 hours, what happened? These are 2 hours. From here to here is 2 hours, not so? What happened?
The lorry then stopped for 1 hour.
That means this still remain what? 100, and that's 10. Not so? Go ahead.
It then proceeded at a steady speed of 4 hours to station.
At a steady speed of?
For 4 hours.
They didn't tell us that distance part, but remember, you are left with the how many kilometers? For 4 hours, that's p.m. 11, 12, 1, 2 p.m. Okay, 2 p.m. Which distance? Because the total 360, not so. The distance here, you'll know it. We shall calculate it later. How many hours are these? 4 hours. Okay, go to a minibus.
A minibus leaves station B at 8 p.m. for station A.
Okay, wait a little. Time. Leaves at what time?
At 8 a.m.
And it's leaving?
Station B.
And at station B, we are at what?
360.
But you know that that's the 0. Yes, because we are coming from now up to. Okay, what happened?
And moved non-stop for 1.5 hours.
That means reached at, that means reached now A, because A is the starting, this is B. Now this time is how long? 4.5. How long is, how will it, what time will he reach? 12:30 p.m. Yes, now we can draw. I hope it's fair work. Is it hard? No. Nope. Nope. A distance time graph showing the journey for, the journeys for a lorry and a minibus. Okay. Now you are going to help me with the scales. Remember, vertically, the maximum distance is 360. Yes, 360 minus 0 divided by 10. Yes?
40.
You,
Okay, it's
36. But that is 40. 4 is not fair in plotting. It's always 5, 1, 2, or 5. That means we can use 50, 50. They said use what? Please. Why didn't you say that? Represent? 40. Yes, you didn't tell me that. 0, 40, 80, 120, 160, 200, 240, 280, 320, then 360. That's great. Then horizontally they said use, but the starting person in the earliest time is 70.
Yes.
That represent how many hours?
1 hour.
That means 7 a.m., 8 a.m., 9 a.m., 10 a.m., 11 a.m., 12 noon, 1 p.m., then 2 p.m. Is it the maximum, the highest?
Yes.
Okay, time. Yes, how many are these? 1, 2, 3, 4, 5, 6, 7, 8. Do you believe that? Okay, we start with the lorry. The lorry 0 goes with 7. Then, where will be 50? No, you divide, the easiest way, you first, this, what's what, 40, because each one square would be what? 10 is 40.
Yes.
If 10 small squares is equal to 40, okay, that means vertically, one small square is what? Is 40 kilometers, not so? Well, these are 10. What of 1 will be 40 out of 10? That means that's what? 4. How? Wait. Are you locating for us 50? Where shall we locate 50? Wait, after 3. Divide 50 by what? How many? What do you get? 50 divided by 4. 12.5. You have a calc. 50 out of 2 is 25 out of 2 again.
12.5.
Because 50, okay, 12.5. That means you count 12 and a half boxes. These are already 10 plus more 2 and a half before you reach the third one. Is that what you said? Okay. That means we are roughly here. The next one is 100. Is 100 there? 100 divided by 4. 25. This is 10, 20, 25 is in between. Not so? That's which time is that? 8. Not so?
9.
It's 9. 8 was for the 50, sorry. Not so?
Yes.
Then 9.
It's for the 100.
Then 10 also.
100.
Okay. Then the last one is?
2, which is 360.
Oh, sorry. Have you captured this work?
Yes.
You've captured it. Okay. Then we can. Hope you are not deceiving, are you? Okay. Now, hope you are understanding these things. This is what you write for your name. You join in also, and you have that. Then there not so. That is our lorry. Then we go to a minibus. We wrapped for the minibus. It was starting at 8. Okay, we need to. Eight is around here, not so, and it stopped at 12 what? 12:30, non-stop. That means this is a what? A mini. They are meeting here. That means you can read the time when they met and the distance at which they What is the first question saying? When the two vehicles met, you just see, because every 10 is 60 minutes, 1 hour is 60 minutes, not so? Are you together? That means you count how many, each will be what? If 10 is 60 minutes, then 1 is 60 minutes. If I've counted like 4 boxes, therefore I will end at 6 times 4, which will give me 24. That's 10, 24, not so?
Yes.
We have to locate like that. Next question.
Find the distance from A where?
From A. A was here, not so?
Yes.
And B is where? You read this distance, not so? On your graph. It is? If you are not aware, you just count the boxes here. If they are, let me think, these are 10, 20, let me take 28. You divide it, you multiply 28 by? Yes. Then right away you'll read, instead of suffering, just multiply by 1 small square the number of small squares. 28 times 4, not divide. Okay? Is that all about the questions?
No, then find the average distance from.
Average speed for the minibus. Is total distance covered over total? Average speed for minibus, it's total distance over total time. Total distance is 360. Total time is how many hours? 4 hours. That gives you 90 kilometers per hour. Okay. I think that's all. Now we are shifting to velocity time graphs, and I think we should end on that. Velocity time graphs. It means speed time graphs. That means we plot speed against time. Now, illustration, you see, the terms used here, we shall have a term called, when the speed is increasing, it normally has this type of fashion. This is time, this is speed or velocity. This part represents constant speed. When the speed does not change, then this part represents that the speed is increasing, and when speed is increasing, we call it what? Acceleration. Increasing speed. Then we have decreasing speed called deceleration. Decreasing speed. And this is the starting speed. Starting speed. This is the highest speed reached. It's called the maximum speed or highest speed attained. And we are doing just one number there. Then we can say it's a day. Now, total distance moved is got by total distance moved is got by finding just the total area of the figure formed there. This is now a trapezium. That means to find the total distance, we just find the area of the trapezium. a trapezium. I want to give you this question and we discuss it and we close from there this topic. Let me read for you this. Are you set? Let me read for you. A car traveling at 12 meters per second. A car traveling at 12 meters per second accelerates uniformly and in 3 seconds its velocity is 30 meters per second, and in 3 seconds its velocity is 30 meters per second. It then continues at this velocity. It then continues with this velocity for another 4 seconds. It then continues with this velocity for another 4 seconds and decelerates uniformly to rest. In 6 seconds. In 6 seconds. Part A. Draw a velocity time graph for the motion of the car. Draw a velocity time graph for the motion of the car. Then part B, calculate the distance traveled by the car. Then next, calculate the acceleration of the car. I think we can discuss now. This part I said that when the question speaks about acceleration, then your graph should bend in a slanting form to show that the speed is increasing. But when they talk about reducing speed or deceleration, you slant downwards in that form. Constant speed we maintain like that. Are we now there? Look at our values there. You will mention them for me. We first have a sketch here. Sketch first, then we can draw the actual graph. Can you, somebody read the question? She read very well. That time, read it again. The starting speed, it is starting with, but the question said velocity, not so? Yes, it starts with 12 here. We are sketching. Okay. Continue.
Accelerates uniformly and in 3 seconds its velocity is 30
In 3 what?
3 seconds.
Its velocity has become
30 meters.
30, not so? That means because we say to accelerate, the graph must what? Slant like that, not so?
Yes.
Okay, go ahead.
It then continues with this velocity.
The velocity remains the same for another what?
4 seconds.
4, that's what now? If it is 3, that's 7. Okay.
And it decelerates uniformly to rest in 6 seconds.
In 6, that's what now? 13. Okay. Okay, go ahead. Decelerates, that means comes to rest. Okay. It doesn't come here. To come to rest is to come to no velocity at all, no speed at all. That means to come to rest is to come and stand at one point. You are not moving, therefore you come to a velocity of 0. Now choose for us the scale under here. What is the scale there? Somebody have a suggestion? Yes, horizontally. This is 13, this is 0. Shall we use 13 divided by 13 minus 0 out of 8? 1 point something. 1.5, are you sure? 1 point divide. You have a calc. You have a calculator.
1.625.
That's tending to 2. That means we rather have it at 2, not so?
Yes.
Then vertically, 0 to 30, we use what? What shall we use? Yes.
Can use
5. You divide 30 minus 0 divide by 10. 3, which we can use 5. That means 0, 5, 10, 15, 20, 25, and finally 30. That's the velocity in meters per second. Here we are using what? 2 to 4, 6, 8, 10, 12, 14. This is time in seconds, not so? We start. Just go at 12. That means you should be able to locate 12. We said establish the meaning of 1. The difference is 5 divided by 10, 0.5. Now 0.5, 12 divided by 0.5. 24 boxes. This is 10, 20, then I count more 4. Not so? This is what? 12. Then 30 goes with 3. 3 is in between here, that is 30. Then 7 goes with also 30. Not so? Then finally you are at 13. You join with a ruler. Join with a ruler here. Sorry. Then a ruler. Definely. Okay. Now that is our graph that we wanted. That is our graph that we wanted. Now let us try to to answer the questions, a velocity time graph for the journey. What was this? Which machine was moving? For the journey of a car. Is that right? For the journey of a car. Now, the next part is to find the total distance that the car has traveled. Make sure you are including the what? The scale. Include the scale there. Is that fine? Now, the next part is to find the distance. How do you find the distance? We say the distance, just get the area under the graph. We divide it. Just divide it into several shapes. This is, I think you see that? Could we use the whole of this as a trapezium? Okay. Okay. That means I will have area 1, area 2, and area 3. Now, area 1, we say distance moved is area 1 plus area 2 plus area 3. Now, this is a trapezium. Since it's you see that the height is 3. Yes. This was 3. This is 3. Then from here to here was 12, not so? Yes. This is 12. Then from here to here is 30. Area of a trapezium is a half height into A plus B. And this stands for A, this stands for B, this stands for height. Therefore, a half height into 12 plus 30. Clear? That gives us a half times 3 times 40. 42 by 2. That's what? 21 gives you 63 meters, not so? Then find another area 2. Area 2 is a rectangle. You can invert it and write it well. From here to here, this is 7. This was 3. You subtract 4. That means the width is 4. Then the length is 0 to 30. That is 30. Therefore, area is equal to 30 times. Don't say the area is squared. No. The units of this on multiplication with the time, they cancel. Because you'll have meters of a second per second times again a what? Then the units will what? Will cancel. Therefore, the area for this case is just in meters, because we are multiplying meters per second times seconds. Okay. Area would be length times width. Are you okay, Grace? Times 4 giving us 120. The last part is a triangle. That's area 2, area 1, then area 3 is a triangle. Okay, give me the height. What's the height? What is the base? Base is 4. You are subtracting 13 minus 7, which is 5. That's very good. area is a half, base height, which is a half times 30 times 5, that gives you 45 meters. Therefore, total distance add 63 plus 120 plus 45. That gives you 228 meters. Okay, that's good. Now the last part of the question was find acceleration. Acceleration is change in speed. Change in speed, we just find the difference in speed out of time between this region. Because you have a problem. It's 75, not 45. Why did you allow me to write 45? Yes, what do you get now there? And it's Mokisa who gave us. Okay. It is the teacher who put it. Okay. Now look here. Let us finish with acceleration and we close this topic. Now acceleration only occurs in this section, and we find the change in speed out of change in the time. This one you've captured it. How we move? Let me squeeze acceleration somewhere here. Acceleration, we have said it is equal to change in velocity out of what? Change in time. You'll meet more of that in your physics, but for us we don't go in detail. Look at the final speed was 30 minus the starting one was 12, and the time difference is 3 minus 0. This is meters per second divided by second. What do you get here? 18 divided by 3, giving us 6 meters now per second. Square, because it's per second and per second again, therefore it's per second what? Squared. Yeah, now that's the end of this topic of graphs. It has been long. Now thank you for attending, and just as a review, we've gone through a lot of work. We looked at finding the scale and for large numbers, and we have really remembered how we can establish the correct scales. Then we went to obtaining expressions in real life situations. Then we went to special graphs. We first plotted some graphs, not so? And now we zeroed down into distance time graph and velocity time graphs. Keep in mind this velocity time graph, area under the curve is the distance, and so on and so on. Let us meet in the next topic. That's topic 4.